This is Year 10 Physics, Module 2, and the Module 2 was called Good Vibrations, and it was mostly about waves and sound. And this is a revision podcast for that unit. So these were all the lessons that you did. Lesson 1, waves, 2, the different types of waves, 3 was called invisible waves, 4 was good vibrations, 5 was the speed of sound, 6 was seeing sounds, 7 was echoes, 8 was sound and noise pollution, 9 was about the decibel scale, and 10 was calculating pressure. So we're just going to start off with lesson 1 about waves. Okay, so lesson 1 about waves. The first little bit here is a definition of waves. And waves transfer energy. So this is your definition you have in your notes. Transfer energy without the movement of the particles from one place to another. So this is a definition you have in your notes. I just scan in that a wee bit, it doesn't come out too well. So it's waves transfer energy without the movement of particles from one place to another. So the picture then, or the pictures, just show a couple of examples of waves. This is a wave on a string. This is sound or music, which has been produced by sound waves. And these are light waves, which are coming from a very distant star. So you did a series of experiments where you went around the room to see what caused waves. And waves are actually caused by vibrations. Some kinds of vibrations, whether it's a string vibrating, whether it's some kind of sound, something that's making a sound that's vibrating, or whether it's electrons and nucleus of a star, of the atoms that are found in a star. So the next little bit is about the properties of waves, and these are the things that we have to learn to label. And so you can see a diagram here of a wave, a typical wave that we might draw. So you can see there's the wave going up and down. The top of the wave we call a crest or a peak, and the bottom of the wave, it hasn't come out too well here, it's in white, it's called a trough. You can see there at the bottom, called a trough. We have a couple more definitions. One of the definitions is of the amplitude of a wave, and the amplitude of a wave is from the rest position to the top of a crest, or from the rest position to the bottom of a trough. So that's the height of a wave, and it's always from the middle part, because if this was water and it wasn't disturbed, it would be flat. But when the wave passes by, then parts of the water move up or down, and these are crests and these are troughs. Another thing that you can see here is this strange looking symbol, and that strange looking symbol is called lambda, and lambda is the symbol we use for wavelength. So I'll just write it here. And the wavelength of a wave is from a position on one wave to exactly the same position on the next. In other words, from something like a crest to a crest, or it could be from a trough to a trough. You can see it labelled down here. Or it could be from one position on one wave to the same position on the next. Now, you have to be careful if you're going to take it from the middle position. The wave has to be doing exactly the same thing. And so therefore, this wave here is moving down. Unfortunately, that one's moving up, so that's not a wavelength, but over here it's moving down again. So you can see these two bits are parallel to each other, and therefore that's a complete wavelength. The other way to look at that, if you were going to do it from the middle, is that a complete wave has got one crest and one trough. So there's a trough and a crest. So this here would also be a wavelength. There's a crest and a trough. Or this one here could be a wavelength, crest and a trough. It could also be from one position on one wave, and I'm going to mark there, to exactly the same position on the next. Now this isn't the same position because this wave's gone down and this one's gone up, so you have to go over again, and there would be the same position roughly, and therefore that distance there is going to be one complete wavelength. So the two things you need to know are the amplitude, which is the height of a crest above the rest position or the depth of a trough, and the wavelength is the distance between one place and one wave to exactly the same place on the next. So this is just us filling in the words here. The amplitude is the height of a crest above its rest position, or the depth of a, and of course the word that goes in there is a trough, below its rest position, and that is called its amplitude. Wavelength, the distance between one place on one wave to the corresponding place on the next or adjacent wave, is called the wavelength. It is measured in meters. And its symbol hasn't come out here, so I'm going to draw it in at the end. Its symbol is lambda. Properties of waves, this is something else which needs to be learned, and if you always try and remember this definition, it will always help you work out frequency. So frequency is how often something happens. In terms of waves, it's how many waves pass a given point in 1 second, and that's called frequency. So it's a number of waves which pass a point in 1 second. It is measured in something called hertz, and that's shortened to Hz, and its symbol is F, so we just use an F for frequency. Now, this is just a little table which has got some numbers in it for you to do a calculation. The first one here tells you that there are 6 cycles, so I'm going to draw 6 cycles. 1, 2, 3, 4, 5. There are 6 complete waves. So there's 6 cycles. The table at the top tells you there's 6 cycles there, and it takes 2 seconds for the 6 cycles. So in other words, there's 6 waves. So we know that frequency then is the number of waves that pass a point in 1 second. This tells us there are 6 waves passing in 2 seconds. So our frequency is 6 over 2, which gives us 3 waves in 1 second. Next one has got 10 cycles. I'll make these a little bit smaller. 2, 3, 4, 5. There's 10. And there's 10 waves in 2 seconds again. So again, frequency, we want to find out how many there is in 1 second. So you divide 10 by 2, you get 5. So that wave has a frequency of 5 hertz. And the last one, you've got 1 cycle in 2 seconds. So I'm only going to draw 1 cycle there. There's 1 complete wave in 2 seconds. And again, we need to find out how many in 1 second. So if there's only 1 in 2 seconds, therefore our frequency is 1 over 2. And the answer is 1/2 hertz. Now, we can then use an equation to calculate the speed of the wave if we know its frequency and we know its wavelength. So we calculate the speed using V equals F lambda or lambda F. V stands for velocity or speed. So F stands for frequency and lambda stands for wavelength. So we're given a question here. A wave has a wavelength of 6 meters and a frequency of 5 hertz. What is the speed of the wave? So V is equal to lambda F. Always write your equation down. Write an equal sign underneath. Wavelength, we're told, is 6 meters. Frequency, we're told, is 5 hertz. And 6 times 5. Again, put your equal sign underneath. Give your answer, and speed is always measured in the number of meters travelled per second, and so you always give your answer with a unit. And the last slide in this lesson is all about the number or the speed of different waves, and it's given us 5 different waves, and you have to work out either the speed, the frequency, which hasn't been marked in here, just put it in, the wavelength, or the wavelength. So the first one's nice and easy. A wave, and we're asked to find V. So I'm just going to write the side V equals lambda F. And that's going to be equal to 2 times 1.5. And 2 times 1.5 gives us 3. The Mexican wave this time, we are given a a wavelength and a speed. Now you can use your little triangle to rearrange that equation. I'm just going to draw it up in the corner. I'm sure you've seen this before. The line across is a dividing line. The line down is a multiplying line. And so therefore V equals lambda F. Lambda and F are multiplying each other. They must go into the bottom. And V is at the top. And so if you need to find, in this case we need to find F, cover up the F, and what are you left with? You're left with V divided by lambda. And so therefore F is V over lambda. And V is 8 and lambda is 40. So you have to do that on a calculator. And when you do that on a calculator, it comes out to be 0.2. So of course you can stop the podcast at any time, do the sum, and then check the answer. Next question, this time we're looking for lambda. So we're looking up again at the triangle, put your finger over lambda, and you're left with V divided by F. So lambda equals V over F. And this time V is 339 and F is 256. So again, you'll have to do that on a calculator. The answer rounded up to 2 decimal places is 1.32 metres. The next one is a wave on a rope. We're looking for V again this time, so that's nice and straightforward. V equals lambda F, and that's equal to 0.8 times 3. And 0.8 times 3 gives us 2.4. Last one, we are looking for lambda. Cover up lambda in the triangle, you get V divided by F. So lambda equals V over F. And that's equal to V is 339 over 35,000. Now it's really tempting all the time to divide the big number by the wee number, but that's not always the case. And so you need to be very careful about that. Again, do this on the calculator. Stop the podcast if you want to get the answer. And the answer, I've rounded it off to 4 decimal places. It's 0.0097 metres.